Hi, welcome to Turkish Engineering. Let's solve some problems for acceleration in a plane. We will start by just a simple example. I know my x velocity, x-axis velocity. Okay, a jet plane is moving and in two directions. Okay, it's moving in a plane, so in two directions. So our x velocity is 665 kilometers per hour. So I will multiply this one to get rid of kilometers. So I will put here 200 meters will be equal to 1 kilometer. So this actually 1 over 1 because 1000 meter will be equal to 1 kilometer. So when I'm multiplying this one by this, there is no effect. So that will be same idea, but I will get rid of kilometers. Then I will use, I must get rid of 1 hour. So I will put 1 hour above, and I need SI units, meter per second. So here I will put seconds. But in 1 hour I have actually 3,600 seconds. Okay, in 1 hour I have 3,600 seconds. So the hours will be cancel each other. So I will get the velocity in SI units, which will be needed. So 665 multiplied by 1,000 divided by 3,600 will give me the velocity in SI units, which is meter per second. So this is 184.7. This is my velocity in x. What about Vy? Actually, it is 420 kilometer per hour. So we will make the same idea. So we will use the same multiplication. So I will just copy paste. So I will get the solution here. For the SI unit, I must use SI units. So here just I will need to change this one. So 420, put it, then you will get 116.6. Actually, it is nearly 6666. It's coming like this, so it is nearly equal to 7. So I will put 7. When I round it, it will be 7. So this is my Vy. Actually, this one time equals to 445. So this is the first case. Okay, this is the first case. When time, this is for time 1. Okay, time 1. And I have time 2. So I must put my values for time 2. What about time 2? My Vx will be equal to just this one. And actually, I don't need to put the same one. I will just put the solution. So here, instead of 420, I will put the other value, which will be our velocity. That will give me the velocity in SI units, meter per second. So it is just 235.5. Let's put 6, round it to the 6. Okay, meter per second. What about Vy? It's the second case. Okay, actually, these are initial values. Okay, just put initial here because the other one will give me the second case. So here I must put initial and here final. So this is initial x and initial y, and here final of x and here final of y. The final of y, actually it is 350 kilometers per hour. So I will use the same idea to find what's my velocity in SI units. So instead of 848, I will use 350 to just take the SI unit velocity. That will be 97.2 meter per second. So this is when time equal to t2. This is my t2 velocities. For this time interval, find in the first part the x and y components of the plane's average acceleration. So it's asking about ax, but average acceleration. The average acceleration can be calculated by delta v, but in x-axis, divided by delta time. So that means this is v final x minus v final 1, v initial x. What's v final 1? V initial x divided by time final minus time initial. Okay, so what is v final in x? Actually, this one, 235.6 minus. Actually, let's put the units. Acceleration will have meter per second unit divided by second. So the acceleration unit will be meter per second squared. This is SI unit for the acceleration. Minus initial x. Initial x will be this one. So 184.7 meter per second. When you divide meter per second by second, you will get just meter per second squared. So the first time, actually this one, and the second time and final time is 747. 747 is final time, and 445 is, actually these are seconds in units, okay? But when I put seconds, sometimes you are saying it's just as 5, so I will put it smaller, okay? So I will make this calculation to get the acceleration, actually the average acceleration, not instantaneous acceleration, because I'm taking final and initial cases, then dividing by the final time, initial time, that will give me the average acceleration. But if I'm asking for instantaneous acceleration, I must use actually calculus to find instantaneous acceleration. But in this course, we will not use instantaneous acceleration. Actually, for all cases, we will use constant acceleration. In our problems, we will use constant acceleration. Maybe you say we are taking basic physics and it will not work. No, it will work and it's powerful. Why? Because acceleration sometimes will be constant, and in real life you can apply this basic algebra-based physics to real life problems. For example, projectile motion. When you throw something, your acceleration will be constant because your gravitational acceleration is constant in the Earth. So don't worry about the basic part of physics. Just be confident, and that will give you the power for calculating real life examples. Actually, for basic problems, you won't need to know high level of physics and calculus-based physics. So you will see that in part 3.3, the projectile motion, we will make some cool problems. We will solve some cool problems by only basic algebra physics. And as I said, we won't take any problem with instantaneous acceleration. Okay, so the acceleration will be constant and is given, so we will make our calculations. Here, let's calculate average acceleration. Just put the point, then 7.47, then 4.45. I will get the acceleration. So it's nearly 16. It's nearly 16 meter per second squared for the unit. What about the y? So I must find the y, and by the same way, delta vy, delta t, and v final of y minus v final of v initial of y, v initial of y, t final minus t initial. So what about the initial y? It's 116.7 minus, just put meter per second, minus 97.2 meter per second. What about the times are the same? So you will get the answer. Let's take our calculator. Here I will just need to change these one. Minus. So I will get the acceleration in y. That will be 6.46. 6.46 meter per second squared. So now I know what's acceleration in x. So I will put my acceleration in x. This is nearly 16, and I have 6 in ay. So actually our acceleration is this way. Okay, it will be just a straight line like this, and will give me the hypotenuse. So this is the a, and I have an angle like this. So the second part, the magnitude and direction of its average acceleration. In the first part, in part A, I made just the acceleration. I calculated the acceleration in x and y directions. But what about your resultant? This one is important. So you must calculate this one. How can I calculate it in part B? I will use basic vector just relations. I must take square of ax plus ay and take square root of it to find the magnitude of acceleration. So what about ax squared, 16 squared, plus what about this one? So 6.46 squared. I will know what's our resultant acceleration. So it is just 17.25 meter per second squared. This is my acceleration. What about its direction? Actual direction means what's your angle, and you are going by which angle. So I must calculate theta. If I know the magnitude and if I know what's theta, so the vector is completed. You know the magnitude and you know the direction. So the vector will only have two things: the magnitude and direction. Magnitude is this one, and direction is actually the angle. So put your angle. So it will be just AY divided by AX will give you the theta. So put my AY, it's 6.46 divided by AY, and it is 16. Actually AX, this is AX. So I will get the answer here. Put shift, then tangent, so you will get arctangent. Put your AY, it's actually 6.46. Then put your AX, you will get the, actually it is nearly equal to 22 degrees. So this problem is completed. Actually, you will start by analyzing the velocity changes in x and y, then find acceleration in x and acceleration in y. Then you can calculate for your resultant acceleration. What is your total acceleration? Then just use some basic trigonometry to find what's your angle theta. This is just we finished the problem. So we will move to second problem. Yes. So here I have a particle. What's particle means? Actually, just any car, any object in space can be treated as particle. Sometimes, in some cases, I can treat a man or a car or a pool ball or a projectile as a particle and make our calculation. So it's just a point moving in the space, okay, a particle, which will start from rest. So that means our initial velocities in x and in y, they are equal to 0, right? Because I'm at rest at the beginning. When time equal to 0, I'm at rest. But I have an acceleration which will make me move, which will give me start to move. An acceleration vector has magnitude 4 meter per second squared. So I will put my acceleration vector, this is our A, and actually the A has magnitude of 4 meter per second squared. What about the angle? What about the direction? Direction has just 30 degree. Okay, so I have here 30 degree. And as you know, for any vector, I must have x component and y components. So here I have AY. Let's calculate them because we will need them. Actually, the question is asking for what are the components of its velocity vector 20 seconds later and what is the particle's position at that time. So our time will be 20 seconds. We will use 20 seconds. But let's start by knowing what's our AY and what is AX actually. So AX will be equal to A cosine 30, A cosine theta, and theta is 30 here. So I will put, that will be 4 cosine 30, and AY will be equal to A sine 30, okay, A sine 30, and actually it is 4 sine 30, okay. That will be equal to what? I will calculate that. So 4 cosine 30 will give me just 3.46. And what about this one? Actually, sine of 30 will give me half. So it is just easily 2 meter per second squared. So I know the acceleration in y and acceleration in x. So I can find part A. It's asking for when time final equals to 20 seconds. Okay, what is Vx final? And what is Vy final? And actually, we will calculate for V also, the resultant velocity. Then we will see what is B, what is the particle's position. So we will solve for displacement in part B, but we will start by just velocities. So Vx final will be equal to Vx initial, okay, or we are putting the initial first. Sometimes I'm just forgetting. So I must put final here. V final x will be equal to V initial x. Actually this one is coming from our introduction. I will use this formula, okay? Just take it. Copy. Paste here, okay? Okay, so I will use this one. So v final x, I'm asking for it, will be equal to v initial x, and it is actually given, it is 0, it's starting from rest. What about ax? I calculated it is 3.46 meter per second squared. Multiplied by time will give me the unit of meter per second, which is unit of the velocity. What about the time? Actually, it is given, it is 20 seconds. So I will get our final velocity. So I will multiply just 3.46 by 20 seconds. That will give me the final velocity, which is 69.2. This is final velocity in x. What about the final velocity in y? Actually, I will use a formula which is, will come from here. So let's take this formula. Just copy and here paste. Okay, so our final velocity in y will be equal to 0, because initial velocity in y is 0. I started from rest. So plus acceleration in y, I'll calculate it here, was 2 meter per second squared. So I will put here 2. What about the time? Is 20. So I will get 40 meter per second. These are my final velocity components. What about the v? Actually, that will be v final. Actually, v final. The final resultant velocity will be v final x plus v final y, but squared 1. So you will get the square root of 69.2 squared plus 40 squared will give you the resultant velocity, which will be just this one. Actually, this amount you can calculate it by another way. How can you calculate this one? When you take the 4 meter per second, your acceleration, actually I will use this formula. Let's take it, and you will see that they are equal to each other. You can calculate by this way. Actually, when you put, these will be similar to each other, okay? So it can be calculated by second way. Alternative method. Alternative method. I will put here, it is nearly equal to 80, right? It is nearly equal to 80 meter per second. So I will round it. Actually, it must equal to 80, but I made some roundations before that made it is not equal to 80, but just nearly to 80. So I will put 80 because actually in real case, which will be coming from alternative method, it's actually equal to 80. Why? Because our v final will be equal to initial velocity, which is 0, because I started from rest, plus acceleration. What is the acceleration? Resultant acceleration is 4, right? What is the time? Is 20. So I will get 80 meter per second. As you see, each formula you use, you will get the same idea, okay? Because they are related to each other. What about the position? Okay, so in position, you can use delta x and delta y formulas, okay? And delta r will be equal to delta x squared plus delta r squared, okay? This is the first one. And in second method, you will just take delta r will be equal to v initial times time plus 1/2 acceleration times squared. So you will see that these are equal to each other, okay? We will see that they are equal to each other. Let's start by delta x. Must be equal to v initial x times time plus 1/2 acceleration x times squared. This is formula which I stated in the past video, okay? In the previous video. So here, our initial velocity in x, actually this is equal to 0. So 0 multiplied by time will give me 0. So this part is 0. Then I will take half of acceleration in x. So half of acceleration in x is actually equal to what? Where is acceleration? 3.46, okay? It's 3.46. Then what's your time? It's 20 squared. So you will get the answer here. Half of 3.46 multiplied by 20 squared. So you will get 692 meters. This is our displacement in x. What about the y? It is v initial y times time plus half of acceleration in y times squared. Same case here, because my initial velocity in y is 0 because I started from rest. So I will put half of acceleration in y, which is equal to 2 meter per second squared. And here I have 20 squared. So I will get 400 meters. What about this one? Here I will put our known values. So square root of delta x squared plus delta y squared will give me delta r. So it's actually 800 meters. Okay. What about this one? So you will see that they are equal to each other. Our initial velocity at rest is equal to 0. So I will put just half of our resultant acceleration, which is equal to 4 meters per second squared, multiplied by this one will give me 800 meters. So each formula you use, you will get the same idea. It's actually asking particles position. So position will be just like a vector. You can put parentheses. So in x, I'm in position 692, and in y, I'm in 400 meters. Okay, and our actually unit is meter. So this is my solution. And you can put, this is for x and y, okay, x and y axis. What about if I'm putting magnitude and angles? Okay, so I will put r and angle. Actually, this is a coordinate system, and this is the other coordinate system. When you give the r, which is your delta r, it's just this one, okay, in meter, and you give the angle, he will understand, the guy which is asking will understand that actually the magnitude is 800 and you have an angle. So it will give the exact position. You can give x coordinates and y coordinates, that will be enough to understand. Or in the second case, this is the first one, okay. So the first case, you can just give x position and y position. And the second case, the alternative method, you can give the r, which is the magnitude, and the direction, which is angle. So how can we find the angle? Actually, theta will be equal to arctangent of delta y, which is 400, divided by this one. So that will give me the angle of my path. Okay, actually the displacement vector. So let's put 400 divided by 692. That will give me 30. Why it's 30? Actually, I started from rest and I'm moving with 30 degrees. So if I started from here, so I must end with the same direction, because my acceleration is not cannot change. Actually, I was at rest. Then I moved with a constant acceleration, which was constant in magnitude and direction. So I must start and continue at the same direction. So I must end my position vector must be equal to the same angle. The direction of my position vector must be equal to 30. And as you see here, actually they were equal to each other, 30 degrees. So a second way will be just give the magnitude and the angle. Okay, so this is the end of the problem. So we will move to the third problem. Actually, this one is a third problem, which I gave to some of my students to solve it as a homework. So you can take this problem. It's just very similar to this one. Okay, very similar. I just changed the values. Okay, so this is a new problem. You can solve it. Okay, I will not solve it now. So just put here 5 and take your angle 45 and try to solve this question by yourself. Okay, so this will be your homework. Yes, this will be our last problem for this section. Okay, acceleration in a plane. This will be our last problem. So a car is propelled over an xy plane. Okay, with acceleration components. I know I have an acceleration in x and I have an acceleration in y. So these are given, and its initial velocity has components of you can put actually v sub 0x or v sub initial x, v sub ix. So these are similar. So you can put just v sub initial x, just the same as v sub 0x. Okay, the same the same values, but by different symbols and by different representations. You can say it is initial by I, or you can just use the other symbol, which is 0, okay, sub 0x. So our initial velocity components is 8 meters per second in x and 12 meters per second in y. So in unit vector notation, just forget about it. Okay, we are not using unit vectors and just these representations in college, not now. What is the velocity of the car when it reaches its greatest y coordinate? Actually, you are starting from this, okay, from this point, and you have two different components of velocity. So I will put our velocities. So I have here Vx, V sub 0 x, and I have V sub 0 y, okay, V sub 0 y. But I have an acceleration, which will be in two directions also, in x and in y. I will accelerate and increase my velocity in x axis. So I will put my x here, okay, this is ax, but I will decelerate, I will decrease my velocity in y axis, okay, but it is just a little bit smaller, so I will put it smaller here, my acceleration in y. So in some you will move, okay, you will move by this path, okay, until you reach a point here. Actually your velocity in this point in y actually is just getting smaller, right? Getting smaller. You have here v sub 0 y, which is smaller. Here you have smaller v sub 0 y. Here you have smaller and getting smaller because of your acceleration is negative. Until you reach here, your y component will be 0. What about the x components? Actually you started with this one, but you are accelerating, so that will be bigger. Here you will have a bigger one. Here you will have just a bigger one. Here you will have a bigger one, and here you will have a bigger one. When you reach here, you will have just only horizontal component of velocities, okay? So I'm accelerating in x, but decelerating in y-axis. So actually, when car reaches this point, it will just keep going in x-axis in y and in y, but the position in y will be just decreased, because until I reach here, my velocity is positive, okay? But here, I started by 12 meter per second, and let's say that here 10, and here just say it's 6, okay? And here is 4, just 2, 1, and here 0, okay? 0 velocity in y. So that means I stopped at y, and after this point I will go down. I will fall down because my negative velocity will pull me down. So it's asking what is the velocity of the car when it reaches the greatest y coordinate. So I must know what is the time from reaching here to there. So I will put here the final values, okay? This is v final x, and here I have v final y, which is equal to 0. So I can calculate for time by knowing final and initial velocities. Our initial velocity in y, which is 12 meters per second. Our final velocity in y, which is 0. And our acceleration in y, which will be equal to what? Minus 2 meters per second squared. Just put, yes, meter per second squared. And how can I know the time for reaching that point? Okay. What is the velocity of the car? Actually, I will need just vfx. But for solving vfx, I will need this time. So I will first calculate the time, then put it to there. So I will know what is the v final x. Okay. Actually, we have some different methods for solving this problem, but I will use this one for now. And I will just show you a different method for solving this problem. So you will see how can we solve the same problem by different methods. So here, firstly, I will know what's time. As you know, v final y can be calculated by this formula. V initial y plus acceleration times time. Or you know that acceleration in y actually is equal to velocity change in y divided by your time change, right? Your time, you can put time. So when you switch them, you will get that time will be equal to delta vy, so velocity change in y divided by acceleration in y. So you can calculate it easily, okay? Let's move this one. This is the answer key. So I will put time will be equal to velocity change. What about velocity change? It is v final y minus v initial y will divided by ay. Our final velocity in y is 0 and initial is 12 divided by, you must put the signs here. So ay is not positive, it's negative. So negative divided by negative will give positive. Actually, the time cannot be equal to negative value. So if you just forget about this, you will put in the exam the time equal to -9. I will say which universe you are just living it. So in our universe we cannot get minus time. So here the exact solution, the correct solution will be positive time. So it is the minus divided by minus will give me positive. So I have just 6 seconds. Now if I know that from the initial position until I get the final position, the time taken is just 6 seconds. So I can solve for v final x will be equal to v initial x plus acceleration x times time. I can use this formula from the beginning, but I couldn't make it because I don't know what's time. So I calculated the time by just taking the y-axis. Then I can calculate the x final velocity. I know that the initial x velocity is equal to 8 meters per second plus acceleration in x. Actually it is given and it is just 4 meters per second squared, right? So put 4 and I will put my time, which is this. So 8 plus 24 will give me just 32 meters per second. This is my final velocity. What is the second approach for this question? How can I know this this one? By just different approach. Actually it will be what could you do? Actually you know v final y and you know v initial y and you don't know what's time. So you can calculate the displacement in y. So you can know what is the displacement and the highest point by using this formula. V final y squared will be equal to v initial y squared plus 2a y delta y. So by this you can calculate for delta y. Okay, so if you know delta y, then you can use this formula v initial of y, okay, times plus 1 over 2 acceleration in y times squared. So as you know, in this question we are at rest. No, we are not at rest. So you must put here v initial y, then time. Actually here when you know delta y and these are knowns, but the time is unknown. So you can solve for time. But actually if I'm taking this method, I can calculate and I can reach for the solution, but it will be so complicated because I must solve this equation, then this one, then I will put the time to here. So it will be just more complicated. So I will not use this method. I actually did the first one, which is this. First find the time by y-axis initial and final velocity informations, then put your time, substitute your time into this equation which is in the x-axis, so you will find what is the final velocity. I will add a new one, okay, so I will put a new part, find the displacements, okay, so in part B, what is delta x and what is delta y and what is delta r and what is your angle for displacement. So I will put simple equations. Delta x will be equal to v initial x multiplied by time plus 1 over 2 acceleration in x plus time squared. So I will put my initial x which is equal to 8. Then I will put my time, which is 6 seconds, okay. So I'm calculating the delta x, which is from here to there, okay, from this point until here, which is delta x, and I will put my delta y, which is the height, okay. So this one will be delta x and the height will be delta y. So first just calculate this one. My acceleration is positive and its amount is just 4 meters per second squared. Then put your time squared, which is 6 squared, so you will get the answer for the displacement in x. So 8 multiplied by 6 plus half of 4 multiplied by 6 squared, okay. So you will get the solution, 120 meters. What about delta y? So you will put v initial in y times time plus 1 over 2 acceleration in y times squared. Your initial velocity in y actually is 12 or what? 12. So 12 multiplied by your time is 6 and plus 1 over 2. Your acceleration is negative, so you must put negative here, okay. You must put your sign. What about the time? Is 6 again, so you will find the solution. Okay, so here instead of initial velocity I have here 12, and here instead of plus I will put negative because it will come from the acceleration, and here instead of 4 I will put minus 2, and here as you see I put minus here because it will be enough to just take it here. So you will get 36 meter. So you moved, just delta x is bigger than delta y. Okay, this is delta x and this is delta y. So what is delta r? What is your displacement, and that is your total displacement, which is delta r. So delta r will be equal to just square root of 120 plus 36 squared. So that will be equal to what? Let's see. So square root of this one plus 36. Oh, plus 36. So that will give me the solution. It's 125. Okay, 125 meters. What about the angle? This one can be calculated. It is easy. So the angle will be arctangent of delta y, which is 36, divided by 120. So let's make this one. So this will be just end of the problem. Okay, so I will get 17 degrees. Okay, so we finished now. We solved 3 problems, and I gave you one homework, okay, 1 problem. So this is the acceleration in plane. If you understand this one, we are ready to move to projectile motion. In projectile motion, actually, we will use the same equations, but we have a special case. Okay, we will see this special case in the next video. So see you, and thank you for your participation.